Howdy everybody. I've been wanting to make videos on how to fix and repair things for a while, and I didn't have the right recording equipment until recently. Coincidentally, my microwave just broke, so today we're going to fix this Hamilton Beach microwave oven. It's plugged into the wall right now, and it is currently not turning on. You can see there's no light. It's also really dirty, and none of the numbers work. So the first thing we're going to have to do is take this thing apart. Before we do that, let's first unplug the microwave from the wall. Now, every microwave I've taken apart has been roughly the same. There's going to be screws on the back side here, and you'll notice this piece of sheet metal and this are two separate pieces. There's also sometimes going to be screws on the sides, or maybe even the bottoms. But in this case, we just have some screws on the side of this sheet metal, and these 4 screws on the back, which are security screws. So you're going to need a special bit to remove those. So let's go ahead and take out those security screws. I'll show you a trick you can use if you don't have the right type of screw head for this screw. So you can take it out normally, like this, like any other screw. Or if you got a pair of pliers or channel locks, these are just some basic channel locks I have. I'm sure everybody should have a pair of these lying around somewhere, but if you don't, they're very cheap. You can find them at any hardware store. And what you're going to do is we're just going to loosen them up this direction. Whenever you're using these screwdrivers, you want to use them in the direction like this. If you try to screw or unscrew something like this, is a chance that this might slip and not make good contact on it. But because these are sticking out about ½ centimeter, it might take a while, and you're definitely going to beat up the screw and probably even the microwave, but that is one way you can get these undone. You can probably unscrew it by hand once it gets to those last couple of threads, and there you go. It's a long but doable process. All right, one more screw back here. And now we're going to take off these side screws, so we're going to put that bit back in there. We're not going to need it. And let's get a Phillips head out. Once you get all your screws out, go ahead and put them somewhere where you won't lose them. Alright, now this is what I meant earlier. It's just a piece of sheet metal, and what's going to happen is it's going to be sliding out. There's some grooves that it's holding onto, so we're going to push it this way, and it should come off. Just like that. And there we go. So these are the majority of all your electrical components, and I'm going to say it right now before we go any further, do not touch anything in here until you've confirmed that that capacitor is de-energized. So you can see all these different components in here. We've got the fuse, which is this little white piece right there. Right there, that is the microwave fuse, and that's the thing that we're going to definitely have to replace. And then you have a few other things around here. I don't quite remember everything. You've got your light bulb right here. In fact, let's use a pointer. That'll probably be safer to do. You've got multiple door switches. You have one here. There's these little blue things. There's another door switch here. And I think there's one more right here. You also have a transformer in here. And this is your capacitor. This is another thing that we're going to check because it probably will be broken. You've got your fan here and your fan motor there. And that's Yeah, that's pretty much it for all the things we're going to be checking out. And you've got your control board here. And so first thing we're going to do is we are going to check that capacitor, and we're going to make sure it's de-energized. Because if it is stored with energy and we touch it or possibly something else in this microwave, we could very well electrocute ourselves. You can de-energize the capacitor if you know what you're doing, but one thing I would recommend doing is to use a multimeter, like one of these two. They're basically the same thing. This one just measures amps in a different way than this one, but you don't need to do that for this purpose. You just need to measure volts, and later we're going to use the ohm meter to measure other things. So you just need a basic multimeter. So we're going to flip our multimeter. This is a manual. There's no auto ranging on this one. So an example of an auto ranging multimeter would be something like this, where you set it to your voltage, and it'll tell you what it is, what voltage it is. It'll automatically adjust the range. You know, maybe it'll be 1 volt, or maybe it'll be a centivolt, or maybe it's 1,000 volts. And then you can select DC or alternating current. Although your cheaper capacitors like these probably aren't going to have auto ranging, and you're going to have to find out if it's alternating or a direct current that you're measuring. So this would be the alternating current, and we're not measuring alternating current, we're measuring the direct current. So we have different ranges here. You've got, this is measuring millivolts, this one's measuring volts, this one's measuring decavolts, this one's measuring 200 volts. It's all we're doing here is just choosing how big or small of a voltage we want to measure. We're going to set it to the largest setting because this is a 2100 volt capacitor. You can see these two leads on the capacitor. You've got this one, and then you've got the one below it right there. So we're going to stick one of these on the positive and one on the negative. So just to make this easier, I'm going to take these caps off just so I have an easier time getting in there measuring the voltage. And as long as you're just touching a piece of the metal of it, like you can touch this part right here, you'll get an accurate reading. And this one, we're going to stick it in here. We are reading 0 volts, so we don't need to de-energize the system. However, I'm going to show you how to do it just to be safe. Now, there's different ways you can de-energize it. There's ways where you can use a screwdriver or just 2 pieces of metal. You'll touch one end with one tool and then one end with the other, and then you'll cross them, and you'll basically cross them like this and touch them together to short out the circuit. If this was a fully charged capacitor, it could be a little dangerous doing that, especially if you don't really have the proper tools. If you use a pair of pliers like these that have this very weak insulation on it, you could possibly electrocute yourself. Anyways, the point is, measure the voltage on here and make sure you have a tool that can protect you from those high voltages. That's all that matters. But since it's reading 0 volts, we can safely de-energize it even with a pair of pliers like this. So we'll go ahead and touch both leads together. Alright, so I'm touching both leads. It's now shorted out, so it's safe for us to touch the electrical components in the microwave, especially that capacitor. Speaking of which, we're going to take those wires out and we're going to test it and make sure the capacitor is good in a minute. If your microwave's not turning on because it broke, this is more than likely one of the components you're going to have to replace. And all this is just a thin piece of wire that's surrounded by this ceramic. And you can see the rating of the wire. It's very hard to read. Barely make out these numbers. Right there. And what that says is that says T15AH250V. What that means is it's 15 amp fuse and it's rated for 250 volts. So you're going to need to get a replacement fuse because most of these microwaves don't have one. So you're going to have to order one of these. You can probably find one on Amazon. You can probably go to a hardware store and find some fuses like this. Make sure you get the right dimensions down because it's going to need to fit on these 2 terminals right here. or wherever the fuse you pulled on your microwave is, you need to make sure it's the right size. Now that we pulled the fuse, the next thing we're going to do is we're going to take out this capacitor. This is a unique kind of terminal because you can't just pull this out. You actually have to depress this little piece of metal here in the middle in order to take out and remove this thing. Never really seen one like that, but it's pretty neat. Next thing we're going to do is we're going to take out, we're going to move this fuse somewhere. Next thing we're going to do is we're going to take out this bottom one. Now that we remove these two, let's move them out of the way. Now we're going to need to take out this screw. We're not going to take this off just yet. We're going to leave it on there, but to take out this capacitor, we're going to have to take out this screw. Now, some of these microwaves have some hard to reach components, so I would recommend getting yourself a small ratchet like this that can accept small screw heads so you can get in there and not have too much difficulty taking out screws. Okay, I got the capacitor out. I took this piece off, which you'll want to keep. This is the high voltage diode. I don't know exactly how it works, but it's important. Keep it, don't throw it away. Now there's two things you want to look for on this capacitor. Before we decide what to do with this thing, there's two things we need to look at. This is the rating of the capacitor right here, which is 0.8 microfarads plus or minus 3%. Now this plus or minus 3% isn't as important as this number right here. This is basically how much capacitance that this capacitor has. And this other number here, yes, hello cheese, that's my cat. This other number, 2100 V AC, that is 2100 volts alternating current. That is the rating of this capacitor. Now, you don't have to get a capacitor that has this exact rating. You can get one that has a higher rating. However, if you do that, you're probably spending more money than you need to. But you definitely don't want to get something with a lower rating because there's a chance that it shorts out and breaks the capacitor in the future. So we know that it's not just the fuse that broke, because normally the fuse breaks because there's a short somewhere in the system. So the first thing we're going to check out is this capacitor. How do you tell if a capacitor is bad? Well, there's two ways you can do that. Not all multimeters can read capacitance. Normally, the pricier ones will. You'll probably have to spend about $80 to $100 to measure capacitance. But what we're going to do is we're going to switch to this mode. We're going to select the capacitance mode, and we're going to measure. It's going to be a little difficult to get this thing. And now we're going to try to measure the microfarads of this capacitor. So we're not reading anything. It says OL, which means there's some sort of error. Probably there is a short somewhere in this capacitor. Now, to check if a capacitor is shorted, you can use that other multimeter, but I'll show you how to use it on this one. What we're going to do here is we're going to switch this over to this little icon here. Now that means it's going to beep whenever we detect continuity in the system, or if there's a short. Now we're also going to be measuring the resistance of this capacitor. You'll see here that if we put our test leads on, it should read 10 mega ohms. That is 10 million ohms of resistance. If we read anything less than that, it's probably shorted out. So we'll switch over here to the mega ohms and we'll measure it. So we're not reading anything, absolutely nothing. This is what we'll switch it here, and 1.3 ohms. That means that this capacitor has shorted out and it's bad. We're going to need to replace it. I bought this replacement capacitor on Amazon. As you can see, it's the same microfarad rating and the same voltage rating. It doesn't have the plus or minus 3%, but as I said, it's not that important as the microfarad and voltage rating. So we're going to switch this back to capacitance. As you can see there, it's reading 1.1 microfarads and not 0.8. I'm wondering if they just slapped a sticker on this, but what can you do? I had a feeling this would happen, so I went ahead and bought another capacitor that didn't look like it was some cheap Chinese knockoff. So this one, as you can see, it's made by the same manufacturer, and this one's 0.91 microfarads. So now let's measure this one. As you can see there, it's reading 0.91 microfarads. And this one, this cheap Chinese one, is reading 1.1. Now if I stuck this in my microwave, that extra capacitance could put more workload on the microwave, making it stronger, but it could also wear out some of the components. This is very clearly not a 0.8 microfarad capacitor, so we're going to toss this one out. And we're going to put this one in. Now this is probably as good of a time as any to give you some advice. Before you take any wires out, before you take any components out, take a picture of it so you know how to put it back together. For example, this capacitor, if it had a positive and negative terminal, which I'm pretty certain it does, it would be very important that I put everything back together exactly the right way, or else there could be problems. But luckily I remember, and I also took a picture. So we're going to put this capacitor back on with this high voltage diode. Now it doesn't really matter which terminal on this capacitor that you put it on, it's the same thing. Just make sure you put it on the right side, the positive or the negative side. In this case we're going to put it on this side. I don't even know which one's the positive or the negative because there's no markings. So we're just going to put it on this side. Are these different terminal sizes? Oh my god. So here's something to look out for. These terminals have different size pieces of metal, so that's going to be a bit of a complication. Unfortunately, this cheap Chinese version has the right size terminals. What are you going to do? But I actually bought a 2-pack of these microwave capacitors. This one's the same as the other one, at least that's what the label says, but let's measure its capacitance and see if it's the same. So we can see here, it's reading 0.87 microfarads. Now, that's not exactly 0.8, but it is also closer to the range we want than the 0.91 capacitor I also bought. It's rated for the, it says it's rated for the same voltage, and it's got the correct terminal sizes, so I'm going to go ahead and slap this thing in there. Alright, so all you're going to do is you're going to put this diode on. You're going to basically slide that little metal, mustache shape, or I don't know what other shape to call that. You're going to slide that onto that prong inside of here. You're going to put this metal little housing holder inside of it, and this will hold that capacitor in place inside of here. Next, we're going to put this part of the capacitor clip in this little hole here, like that. So probably should have done this first. You're going to take this diode and you're going to line up the hole with the hole that that screw was in, almost like you're connecting a ground wire to some plate. And you're going to take that screw, put it through that hole and that hole, so it's like that. Next thing we're going to do is we're going to turn this thing to righty-tighty, or clockwise, or whatever. Alright, that's in there good. Now the next thing we're going to do is we're going to connect these back to their terminals. So this one should just slide on like that. Same thing with this one. Same thing with this one, we're going to slide it on there. Now that that capacitor's on there, the next thing we're going to do is we're going to replace that microwave fuse with a good one. Again, I bought this like on Amazon. They're not too expensive. I recommend buying more than one in case you put the fuse in there and find out something else shorted out, because if something else shorted out and you put your only fuse in there and it breaks, you're going to have to order some more. So I highly recommend ordering several of these because you might go through them. So we're going to put the microwave fuse in here like that. Many microwaves and other appliances, they'll have some sort of electrical schematic. Either it'll be a piece of paper, or in this case it's actually on a piece of tape on the underside of the sheet metal of the microwave. And you can see here, here's that capacitor that we just put back in there. There's the high voltage diode, and then the microwave fuse is right here. Now another thing, a very common thing on microwaves that also breaks are the switches. You can see we've got 3 switches. We have 1, 2, and 3 switches. These door switches are determined by the door being open or closed. So you can see here it says the door is closed in the schematic, meaning the primary and the secondary switches are both closed, but the motor switch is not. So when the door is closed, the motor switch should be open. We can test these switches by opening and closing the door and putting our test leads on the microwave door switches to see if they're still good. So let's do that right now. So as I said earlier, these little kind of bluish things right here, that is one switch. That is the other switch right here. And then you have a third switch, kind of hard to see, right there. To find out which switch is which, you should probably look at that wiring diagram. We know one of them is open when the door is closed. So if we find out which one that is, we can rule that one out. So we'll try this one in the middle. We're going to stick our 2 test leads in there. One's going to be touching that piece of metal, and the other one's going to be touching this one. And as you can see, there is no beeping on our multimeter. But if I open that door and touch the 2 leads to those, oop, one came out. There we go. It's not making great contact, but that's how we know that that switch is the door switch, or the, sorry, not the door switch, but the motor switch. So that means one of these is the primary and one of these is the secondary switch. But as long as they both work, that's all that matters. So we're going to stick our test lead in there, on that one, and we're going to stick the other one in here. And if we open the door, it shouldn't beep at all. And we'll do the same thing with the other one. So same thing with this one down here. We're going to stick one test lead in that little sleeve there, touching the metal of one side of the switch, and then we'll touch the metal of the other side, and look at that. So the door switches seem to be working properly. Now this is your microwave transformer, and again, be very careful not to touch this thing if it's plugged in or if that capacitor has energy in it still. But you can see you've got this copper winding here, and then you've got another one up here. It's kind of hard to see with all that tape or paper or whatever it is. But what we're going to do here is we're going to set our multimeter to read ohms, and we're going to put one of these, and it's kind of hard to see. You can see 2 leads here. You've got one in the back right about there, and then you got another one right here. And we're going to put one lead on one. Like that. Dang it. And we'll put the other one right here. Oop. So we're reading about 2, about 2, 3 ohms. Okay, so that's good. And this one, actually, if I remember correctly, the transformer, the neutral of the transformer is actually just the housing of it. So we're going to put one test lead here on this one, and the other one we're just going to touch the side of the transformer, and we get 141 ohms. So I'm not sure exactly what kind of resistance we should be measuring on this, but it doesn't seem to be shorting out. I'll be honest, I've never had a bad transformer, so I don't know what one looks like, but that's what I'm reading on this one. Okay, so now we're going to put that top of the microwave back on it, plug it back in, and see if it works. Now, for those who've never had to put one of these back on, you're going to see these almost clips. Yes, my cat agrees. You're going to see these clips on the side and the top, and that's going to clip on to this little metal piece on the microwave. So you can see here, I'm just going to slide it on there like that. And then these side pieces might be a little trickier. Like that. And like this. Now, I'm not going to pick up this microwave, I'm just going to plug it in and see if it works. So the microwave seems to be turning on. Let's see if the clock works. Yeah, clock works. Lights and door switches work. Now let's see if it turns on for a second. Actually, it's not really a good idea to ever cook an empty microwave, so let's go stick something in there. Don't forget to put your microwave tray in the microwave. And we're gonna reheat these Asian meatballs I cooked last night. Okay, moment of truth. Let's see if it cooks for a minute. One thing you should also check is that fan. There is a fan on the back of this, and you should feel air. If you put your hand over it like that, you should feel air blowing through it. So we know that fan and fan motor are working. All right. Definitely feels warm. Let's cook it for another 2 minutes. And I will be right back. And look at that. Nice and steamy. It's a little hot, but hey, that's how you fix a microwave. Alright, so let's put those screws back on. Definitely don't want to leave the microwave like that. In fact, it's probably a good idea to put those screws in there before you plug it in, but I've been messing with so many appliances in these past 2 years that I'm not worried about it. Now, I probably should have demonstrated this, but here's how you tell if a fuse is bad. Yes. My cat's very vocal. So what you're going to do is you're going to put both test leads on one fuse, one on each side. So you're going to have one test lead touching one side of the fuse and the other side. Jesus Christ. My cat has got zoomies. So what you're going to do is you're going to put one test lead on one end of the fuse and then one on the other side, like this. And if it beeps, and if you're reading continuity, that means the fuse is good. This is a bad fuse. Sorry, it's a little awkward doing this with one hand. Let's put it here. Maybe it won't roll around so much. There we go. Nothing. So that's how you know if a fuse is bad. You just put it on the continuity or the ohm meter or the whatever you want to call it, the beep mode, and put your multimeter leads on each side of it. But anyways, that should conclude this. There's really nothing else to do. The microwave works now, and I plan on making future videos on other appliances such as ACs, refrigerators, washing machines, dryers, dishwashers. Anything I get a chance to take apart, I'll try to make a video on it. As always, thank y'all for watching, and y'all have a good day.